everyone, I'm Siddhartha. I'm a second year BTech IT student from NSCC, Kolkata. Now, welcome to our channel CodeChef. Today, we would discuss the problem named as India fights Corona. And the problem code of this problem is Corona. And the difficulty level of this problem is medium. And the prerequisite to this problem is Dijkstra. Now, let us understand the problem statement. So, we are given n cities and m bidirectional road, and each road has a length of di, and there are different cities where the cost of corona testing may be different. Now, suppose there is a city named as A and there is a city named as B. Okay, and the cost of testing in this city is 5 and the cost of testing in this city is 3. Now, there is a road between these and length of this road is suppose 3 itself. Now, if the corona testing is done on the hospital which is situated on the same city, then the cost would be 5. Else, the cost would be the length of the road and the cost at that city. Okay. Now, why I am telling the length of the road? Because we are assuming that cost is rupees 1 per kilometer. Now, we need to tell the minimum cost of each city to test the corona sample. And the thing is that it is guaranteed that there is a path from each city to every other city. Now, let us understand the input and output format. So, we are given t test cases, and in each test case, we are given at first n, m, and then k. What is n? N are the number of cities, m are the roads, and k tell you which cities there is a corona testing center and the cost of it. At first, we would be given k itself. Suppose n is 3 and m is 2 and k is 1. Suppose 2 has a hospital which has a cost of 5, and then we would be given m linkages. Okay, the first is suppose 1 to 2 and then the cost itself. Suppose it is 5 and then 2 to 3 and suppose the cost is 12 itself. Okay, that's why we are told that we would be given k plus m plus 1 lines of input. That is how it should be. And next thing is that we need to print in a single line n space separated integers which would tell the minimum cost of testing for each city. Okay, now let us look at the constraint so that we have a rough idea of what is the upper bound of time complexity we can implement. We are given that n and m do not exceed 2 multiplied with 10 to the power 5 and 4 multiplied with 10 to the power 5. So, in 1 second, we can do 10 to the power 8 operations. So, clearly we can see that we can implement a big O of n or big O of n log n, but not n square, because n square would exceed the time limit. Now, let us look at the sample input and output. So, we are given 3 cities. Now, we are told that in the one city, 1 and second, the cost of testing is 5 and 10. And then there is a linkage between 1 to 2 with a cost of 6 and then 2 to 3 with a cost of 9 itself. Now let us write 1, 2 and 3 where we would write the minimum cost to test the sample. Now let us consider the first city. Okay, to test in that city only we need to pay 5. To test in the second city we need to pay 10 plus the length of the road 16, so we need to pay 16 on the, if we test on the other city, that is 2. So 5 is cheap, so for now our answer would be 5 for the first city. And then let us consider for the second city. So if we test on this city itself, we would encounter a cost of 10. If we test on one, we would encounter a cost of 5 plus the length of the road, that is 11. So which is cheap? Absolutely 10 is more cheap. And then 3. If we go and test the sample in this city, then the cost would be 9 plus 6, 15. 15 plus 5 would be 20. From 3, we go to 2 and then 9 plus 10, which is 19. So the answer would be 5, 10 and 19 itself. Now let us consider for the second sample test case. Okay, so for the first cities, we would encounter a charge of 5 itself, and for the second city, we would encounter a charge of 10. Okay, and then there is a linkage between 1 and 2 with a cost of 1. Okay, and then 2 to 3 with a cost of 9. Let us consider for the first city. If we test in that city only, we would encounter a charge of 5. If we test it on the second city, we would encounter a charge of 10 and the length of the road, that is 11. So 5 is cheaper, so we would use 5 itself. Okay. And then for the second city, if we test in that city only, we would encounter a charge of 10. If we go on the first city, we would encounter a charge of 5 plus 1, that is 6. So 6 is cheap, so we would consider 6 itself. Now for the third city, if we go to the second city, we would encounter a charge of 10 plus 9, which is 19. So this is the first candidate. And if we go on the first city, we would encounter a charge of 9 plus 1, that is 10, plus 5 is equals to 15. So 15 is much cheaper. So we would declare our answer 15, and that is how we need to print it. Now let us discuss how can we solve this. Suppose this is a given graph and we need to calculate for each city the minimum cost. So we can calculate like this, that 3 is the first candidate. Now if we come from 3 itself, which is the candidate 5, 5 and 6, which is 16, and then the third candidate 4, 3, 6, that is 13. So which is the cheapest for 1? 3 is the cheapest for 1 itself. Now let us move to 2, and that is how we can consider for all different cases that which is cheaper among the neighbors. We would go from that city to the hospital which is situated, and we would consider all the hospitals. Okay, at first, so it would give you a TLE because we are comparing all the hospitals. Okay, and the upper bound of the number of hospitals are n, which is 2 multiplied with 10 to the power 5. So it would give you a TLE. What we can do is we can use Dijkstra for every node. Okay, we can use Dijkstra for every node, this as a particular source, and we can move to all this direction, and then we can take this as a particular source and all this visit all the other nodes. That is how we can calculate, but this would also give a TLE because we are considering all the hospitals. But this approach can be optimized. How we can optimize it? We can optimize it in the same way as we implement multi-source BFS. We would do the same thing. We would push all the eligible candidates in priority queue itself. Okay, and then we would start the simple Dijkstra itself, and that is how we can solve it. Okay, now let us see how can we implement this. To store the whole graph, we have used a array of vector of pairs, and then to store the slots of the hospital, we have used a vector of pairs. Now, the next thing which is done is this class of priority queue. The class of priority queue, what it does, it acts as a custom comparator to implement the min heap of priority queue on the basis of second element. Now, if you don't understand this priority class, what you can do is you can simply store the cost on the first element instead of the second element. Now, first, the main function. What I am doing is, at first I am clearing the slots for every test case. I am taking the input of n, m and k. And the next thing what I am doing is I am resetting the value of the distance with the maximum possible, and then I am clearing the graph also. We are given k number of hospitals, so we are taking the input of n and x and y, and then we are pushing it in the slots vector. Okay, and then what we are doing is, this is x, this is y, and this is cost. This means that there exists a path between x and y with a cost of CST. Okay, so we are pushing it bidirectional, so we are pushing it on the both ways. Then we are running a function which is named as Dijkstra. So what Dijkstra does is, at first we have declared a priority queue, then we have pushed all the eligible candidates at first. Who are the eligible candidates? The eligible candidates are the candidates which are declared in the slot vector. Okay, so we are pushing all of that, and then we are running a simple Dijkstra. What we are doing, we are first keeping the temporary. Okay, I have declared it TP, and then we are storing it, and then we are popping it. And for all the neighbors, we are relaxing the cost. Okay, so the cost, if the cost is more, we are relaxing it, then we are again pushing it in the priority queue. So after this function is over, the answer would be stored in our distance array. Okay, and then we are printing from 1 till n itself, after that with the end line. Now, one thing to note here is that to reset the values of slot and the graph itself, and to reset the value of the distance with the maximum possible, because this is a crucial thing which must be done. Now let us submit our solution. Let us click on the submit button. Our submission is queued. Let us wait for the verdict itself. And yes, we got an AC. If you are interested in competitive programming and want to learn and master data structures and algorithms, this is a one-stop destination for you. Every week, we post CodeChef problem explanation, live problem solving sessions, and frequently asked interview problems. Consider subscribing this channel if you haven't yet already.